By Mr. Sushil Reddy in IIT Bombay 2013 Department of Energy Science and Engineering.
Good morning everyone. Is this slide visible? Or maybe if you can switch off that light over now. Okay, so firstly thank you so much for taking out time in the morning, and thank you for organizing this session. This is a pit stop in my journey, which is going on an electric car from Kanyakumari to Kashmir. So today is day 43 of the journey. We started from Kanyakumari 42 days ago. This is a 55-day journey on the electric car from Kanyakumari to Kashmir, and there are almost 28 city stops on the route. So fortunately, I got an opportunity here to stop by and share some learnings from the journey. So the whole point of doing this journey is to share whatever I learn, right? So I'm sure you have a lot of questions about charging, how to charge the electric vehicle if you're traveling such a long distance, and other questions as well regarding e-mobility. So I would like to share today my practical learnings, and also we'll see the electric vehicle afterwards. And I want to keep it interactive, so if you have any questions, please feel free to just raise your hand, ask questions, stop me, let it be as interactive as possible. To start off, we have been seeing these 17 sustainable development goals, right? Now I'm trying to focus this initially because when we talk about mobility, there is a huge shift from petrol diesel vehicles to electric vehicles across the world, right? And there is a reason for it, because electric vehicles have lesser total emissions compared to petrol diesel vehicles. Now anything to do with lesser emissions as a solution contributes towards sustainability and the 17 sustainable development goals. That is why I want to focus on the 17 SDGs first. I'm sure you have seen these, right? The 17 sustainable development goals. Even on the campus I saw it, pasted in different locations. I think it is very important because, okay, maybe I'll ask you a quick question. Do you know by what year does India as a country has a target to set net zero emissions? By which year India aims to achieve net zero emissions? Does anybody know? Every country has a different target year to achieve net zero emissions. So net zero carbon emissions is what? Not 2030? Any other guesses? Sorry? Not 2050? No. Not 2025, not 2030, not 2050, not 35, sorry. Okay, more guesses, more guesses. Sorry? I can't hear you, maybe I'll just walk down. Somebody can guess? Sorry? Huh? Which year? Just guess a year. 2070. Who said 2070? Right, that's the correct answer. So by the year 2070, India aims to achieve net zero emissions, and that is very important for all of you to understand, because you are the generation who will be living maybe near to that year, right? So the aim of today's generation is to achieve net zero emissions as collective species. So mobility plays a small role. That is why I am focusing on these 17 SDGs to begin with. Next slide. इसको fit नहीं हो रहा क्या? हाँ. Okay, so coming to the project which I started in 2016. So the project is called the Sun Pedal Ride, and the idea of the Sun Pedal Ride is to do long distance journeys on electric vehicles. Started off on a solar powered electric bicycle. So you see the picture on the left side. So me and my team, we custom built a solar powered electric bicycle, and we did almost 7,500 kilometers on it. And the whole idea of doing it is to showcase the fact that you can use clean energy to go long distances. Use a free source of energy, which is solar power, and go long distances. And also, you see the picture on the right, it's an electric auto rickshaw. And it has a solar panel on the roof. Now, we did almost 6,000 kilometers in 60 days on a solar powered electric auto rickshaw. Now, these are all journeys where there are a lot of learnings from these journeys, right? From how the journey is in terms of electric mobility, using clean energy, is it technically feasible? So all that feedback is going to product development, and a lot of stakeholders who are working on creating such products for commercial use. So this is a cause, and as a part of this series of journeys, the current journey is happening on an electric car. Okay, a quick mention before we move ahead. So the Guinness World Record is for the longest journey on an electric bicycle. So there are two world records, one in India and one in the US. In India it was 7,500 kilometers. In the US it is 11,800 kilometers. So as a part of this cause, me and my team, we have done multiple journeys, and we have, for the cause, we have 2 world records to our name. Okay, I want to ask a quick question before we go ahead. How many of you have driven electric vehicles? Any electric vehicle? 2-wheeler, 3-wheeler, 4-wheeler? Sorry? None? Anybody? Anybody has driven an EV before? Or sat in an EV? Like 3-wheeler, 2-wheeler, 4-wheeler? Yeah? You want to share any experience? How was it? कोई भी जो भी मन में आता है बोलो, बाइक पे बोलो ना, सबको सुनाई देगा यार. अच्छा, नॉइज कम आता है. ओके, वन ऑब्जर्वेशन इज नॉइज कम आता है. यस. एनीथिंग एल्स दैट यू वांट टू शेयर? लाइक हैव यू सीन इलेक्ट्रिक व्हीकल्स? What do you think? Like, I want to understand from you first before we get into my learnings about electric vehicles. Eco-friendly, zero tailpipe emissions. So basically, it's good for the cities, right? Good for dense cities to replace petrol diesel vehicles. Anything else that you want to share regarding EVs? Okay, so let's move ahead. Next slide. Okay, so this is the current journey that we are doing. The vehicle is the Mahindra electric XUV 400, and it is a collaboration with Mahindra, this particular journey, and we are gathering a lot of data from the vehicle performance, because this is a real world test in a way for a car, and we are testing the battery performance in hot weather conditions. This is peak summer time, and the lithium ion battery pack, the performance of it reduces with hot weather conditions usually. So if you drive in 40 plus degrees Celsius continuously, there is certain degradation of range. So that is what we are testing with the vehicle. Otherwise, that is a route map. Next slide. Next. We have a few partners of the project. I'll talk about it later on. Next. Okay, so we'll do a quick calculation. I think this is the first takeaway with electric vehicles. The running cost of any electric vehicle is almost 70% less compared to any petrol or diesel vehicle, because the fuel is electricity here, right? The main fuel which is powering the battery is electricity compared to petrol or diesel. Now let's do a quick calculation. How much do you pay for electricity at home here in Ludhiana? Per unit, what is the cost? About 10 rupees maybe? 10? Okay, let's consider 10 rupees per unit is what you pay for your home electricity, right? Now if you charge this particular car at your home from 0% to 100%, you will consume 40 units of electricity. So the battery capacity is 40 units. So 40 units into 10 rupees per unit. 400 rupees, right? In 400 rupees, you can go 300 kilometers. The range of the vehicle is 300 kilometers. So in terms of running cost, it is a little over 1 rupee per kilometer compared to 7 or 8 rupees per kilometer in any petrol or diesel car. So this is one big advantage with any electric vehicles. The cost of fuel, which is the cost of electricity, is less compared to the cost of petrol and diesel. And if you do the calculations, the running cost comes to little more than 1 rupee per kilometer compared to 7 or 8 rupees per kilometer in a petrol or diesel vehicle. So that is one big key takeaway. Any electric vehicle, not just this car, be it a two-wheeler, three-wheeler or a four-wheeler, right? So that is one big advantage of any electric vehicle. Next. Okay, so another advantage of an electric vehicle is the fact that it has less moving parts. Now, in a petrol or diesel engine, you have a piston, you have spark plug, you have mechanical differential, all the moving parts, right? But in an electric vehicle, there are very less moving parts. That is why the maintenance cost is almost 30 to 40% less compared to any petrol or diesel vehicle. Primarily, they are electronic components in the electric car. We will see the components once we go to the car. But what I want to tell you is that the maintenance cost is a big advantage. Almost 30 to 40% less cost is what you will be paying for maintenance in any electric vehicle compared to a petrol or diesel vehicle, because the moving parts are not there. Because there is no piston, there is no wear and tear, right? The more moving parts, there will be more wear and tear. That is not happening in an EV. Next. Okay, how to locate charging stations. I think before that there is one more slide, right? Okay, so let's talk about charging. Let's talk about charging. This is an important topic, right? Because ultimately that is the fuel of the vehicle. And there are different pros and cons today with charging. So primarily there are two ways to charge. You can charge at your home. The car comes with a portable charger. You can plug it into any 16 ampere 3-pin socket. I'm sure you have seen 16 ampere 3-pin sockets. I'm sure there are some in the room also. They are heavy load sockets used for air conditioners, geysers, all these heavy load equipment. So you can plug the car into any 16 ampere 3-pin socket. It will take like 10 to 12 hours for a full charge. It is more like overnight slow charging, right? So that is the slow charging aspect. The other side of charging is the fast charging. Have you seen fast charging stations? Yeah? No? So there are a few in some cities. The network of fast charging is still building up. It's not there everywhere. That is still a disadvantage. The fast charging stations, the charging happens at a high current. High current charging meaning it takes less time to charge. So instead of say 12 hours, it takes 2 hours to charge at a fast charging station. So from 0 to full, if you want to charge the car at a fast charging station, it takes approximately 2 hours. Now those stations are not available everywhere. That is another challenge. So availability and accessibility of these fast chargers is a big challenge today, right? And also it is recommended to use slow charging as much as possible to save the battery or to make the battery last for a long time. Now do it with your smartphones also, right? Your smartphones have lithium-ion battery. The same technology is in the car battery. If you fast charge your phones often, it is not good for your battery life of the phone, right? So ideally what you should do is slow charge your smartphone as much as possible, so that you can increase the life cycle of the battery. And also there is one more charging habit or a hack which I can tell you to increase your lifetime of the lithium-ion battery, for example your smartphone. Keep the charge between 20% and 80% as much as possible. Never let your charge of the smartphone go above 80%, or never let it go below 20%. Keep it between 20 and 80%. You will increase the lifetime of your smartphone. It's a hack. It's a very ideal case. Not everybody would be easily adaptable to do it. People forget once they plug into charge. But if you do that, you have a higher lifetime of the battery. So similarly for the car, if you keep the charge between 20 to 80%, you have a bigger lifetime of the battery. Although there is a 8-year warranty which comes with the car battery. So any OEM today like Tata, Mahindra, all these car companies, they give 8-year battery warranty of the main lithium ion battery pack. So it's a quite a long duration of the warranty, right? So do you have any questions about charging? Two types of charging, slow and fast, right? Fast is it saves time but not good for the battery. Slow is of course if you take a long time but good for the battery. And accessibility wise, 16 amp 3-pin sockets are easier to find compared to those big stations which are not available everywhere. So you need to plan in advance. So if you are going intercity, say from Bangalore to Hyderabad, you have to plan where is the charging station, and now we come to how to locate charging stations. How to locate charging stations. Now we all know where petrol stations are there, right? We all know where the petrol bunk is. There is a very good resource called PlugShare. Now you can do this exercise, just Google PlugShare, and what you will get is an open map across the world of all the points where EV charging stations, electric vehicle charging stations are there. So you can locate any electric vehicle charging stations across the world, not just in India. So you open up this map and it's constantly updated, and you can find in and around Ludhiana as an exercise what charging stations or what kind of charging stations are available. Next. Okay, so we did the calculation for home charging, right? So if you charge your EV at home, how much was the running cost? A little more than 1 rupee per kilometer, right? So 10 rupees per unit into 40 units, so 400 rupees for 300 kilometers. Little more than 1 rupee per unit. Now, if you go to a fast charging station, how much are you paying? Instead of 10 rupees at home, you will be paying anywhere between 15 and 20 rupees per unit. So you're paying double the cost. If you take your vehicle to any fast charging station, you are paying double the cost to charge. Now, even if you take double the cost, the running cost comes to approximately 3 rupees per kilometer, right? Which is still less than any petrol or diesel vehicle. Compare 3 rupees per kilometer versus 7 or 8 rupees per kilometer. So you are anyway saving almost 50-60% money just by running this electric vehicle, right? So that is where the cost advantage is, right? It's very very useful if you run the vehicle as much as possible. Next. Okay, so there's another thing which I wanted to mention. All electric cars today have a common standard port of charging. It's not like Android and iPhone have different ports, right? It's a big hassle. So all electric cars today, any brand, take Tata, take Hyundai, take Mahindra, take any brand, all of them have a same charging port. It's called CCS, the standard combined charging system. So you can charge two types, as we discussed, slow charging and fast charging with the same port, right? So that is one advantage with having a standard port of charging in all electric vehicles, right? Next. Okay, so when you go to a fast charging station, mostly these are unmanned stations. So basically there is nobody standing there, helping you with filling the fuel tank. You have to do it all by yourself. So the connector is with the charging station. You go to the charging station, take the connector out from the station, put it into the car, and everything happens online. So all these companies who are setting up charging stations, they have their own mobile application, right, to do the process of charging, to do the digital payments. So all of that is happening online. So there is no intervention of a person there. So sometimes there are network challenges, right? So I have a Vodafone SIM card, which is not the best in terms of network. So where there is no network in smaller towns and villages, you can't even start charging the car, even if the hardware is working, right? So those kind of issues still exist on the ground. So there are practical problems which you face when you're traveling in an electric car, especially from the charging aspect. And some of the charging stations do not work. So online, if you see, it says, the charging station is working. But if you take your electric car there and see if it is working or not, most of the time it does not work because there's hardware issue, there's a connectivity issue. So all these are real issues on the ground today with fast charging stations, right? Next. There's another problem is with charging stations is traffic at a charging station. Now, as we saw, usually it takes 2 hours to charge, right? An electric car at a fast charging station. But what if some of the chargers don't work? So there is a pileup of cars at one charging station. So there is a traffic developed at a charging station, and each car has to wait at least 20 minutes, 30 minutes for a charge, right? And it just adds up extra waiting time at the charging station. So this is one big problem today. We don't have enough fast charging stations. The rate of growth of charging stations is not equal to the rate of growth of cars, right? So we need to have more charging stations and more electric cars or electric vehicles growing simultaneously. Not one should outgrow the other, right? Otherwise we'll face issues like traffic at a charging station, which is not good. It just adds up extra waiting time when time is already being lost in charging, or it takes a long time to charge. Next. There's something called as regenerative braking. Have you heard about regenerative braking? So what happens if when you press the brake in a petrol or diesel vehicle is the energy is lost as heat, right? You won't get the energy back into the engine. But in an electric vehicle, when you press the brake, the motor acts like a generator and part of the energy is coming back into the battery. So that is called regenerative braking. So motor has a dual purpose. It is also a generator when you press the brake. So because of that, there are many advantages in electric vehicles. For example, I was driving from Coorg to Mysore. So Coorg is on the hill station, right? Coorg is a hill station in Karnataka. So it has a higher elevation and Mysore is at a lower elevation. So the whole drive was a downhill drive. So I was pressing the brakes often. Now more often you press the brake, more energy is getting back into the battery, right? So instead of 120 kilometers, which was the distance on the Google Maps, the battery consumption was only 100 kilometers. So there was a 20 kilometer gain just because of regenerative braking. So the more you brake in an electric vehicle, you get energy back into the engine or the battery rather. So this is something interesting to remember with electric vehicles. Next. We are also carrying an extension cord because as you can imagine, it is difficult to find access to a 16 ampere 3-pin socket, right? Wherever we place the car to charge for 12 hours. So we are carrying almost a 10-meter long extension cord, which will give access, at least give help to access the 16 ampere 3-pin socket when we have a challenge in terms of accessibility. Next. Now the main challenge with fast charging stations is the lack of it. We do not have enough fast charging stations. So there is a huge opportunity. So anybody can start their own charging station today. There are a lot of franchise opportunities like Tata Power, for them charge and drive. There are many, like almost 50 companies giving franchise opportunities to start your own charging station. All it takes is a initial investment about 15 to 20 lakhs and you get a payback in 3 to 4 years if the location of the charging station is good. It's a very good investment opportunity because there is a huge rise in electric vehicles and the need for charging is growing at a very rapid pace. So anybody can start their own fast charging station in India today, right? It's a very good opportunity. Next. Somebody said EVs are silent, right? There's no noise. I think he told that there was no noise. So basically, there's no engine, right? There's no engine in an electric vehicle. So the vibrations are not there. And the vibration and the noise is not there because there's only a motor and a battery primarily in an electric vehicle. So there is less noise. Generally there's less noise. But the less noise is not good for people around the vehicle. You have to keep honking at people to make them realize an electric vehicle is passing by. Because in India we are not used to like silent vehicles, right? We are used to like uh, loud vehicles or honking vehicles. It's very difficult to get used to silent vehicles in India. So we have to create that extra noise around the EV, just so that people around the EV know that there's a car passing by or a vehicle passing by. Next. Okay, there are a couple of very interesting research topics. So V2G stands for vehicle to grid. Now imagine electric vehicles are nothing but power banks, right? Electric vehicles have batteries in them, so they are power banks, and they are moving around, so they are moving power banks. Now imagine that energy stored in the battery as a power bank can be shared between vehicles, or that energy can be given to a grid, a home. So it's bidirectional flow of energy. So imagine the scenario where your car is not only taking energy from the grid to charge, but it's also giving back energy to the grid, or your car is charging another electric car, your electric car is charging another electric scooter. So it's shared energy and shared mobility. These are the two very interesting topics in e-mobility, which open up the whole game of energy and mobility. So a lot of opportunities to think of in terms of research, and something called as time of charge tariff. Now imagine all the electric cars, usually people plug in the night, right? You use during the day and plug your vehicle in the night. So your car is charging overnight. Now mostly the vehicles will be charging overnight. So what happens to the grid? The grid is at risk, right? The main electricity grid has to power so many vehicles. So there is a huge load on the grid. So there could be power outage, there could be many challenges with the grid because the peak demand is in the night. Now there is a lot of research going on how to shift that peak demand, which is in the night, to the daytime. Now how can that be done? One way is to incentivize people to charge during the day. Now instead of charging in the night, you pay less to charge during the day, for example, right? So all these are interesting topics to think about, and also grid challenge is another issue to think about when it comes to electric vehicles and the energy demand for charging the EV. Next. Okay, so I'll quickly tell you how the charging works. So there is something called as CCCV. Are there any electronic students here? Electrical electronics engineering? Any engineering students here? No? Okay. So basically, so there is a technique called constant current, constant voltage. So maybe in your smartphone you have seen this. When you charge your smartphone above 80%, usually the time taken to charge is quite high, between 80% to 100%, because the charging current is reduced a lot. So similarly, even when charging the electric car, it takes a long time to charge between 80% and 100%, because the current of charging reduces exponentially after 80%. So that's called CCCV technique, constant current, constant voltage. Next. So electric vehicles have a higher acceleration. They have a higher torque compared to a petrol and diesel car, because the power transmission is instant and there is less loss of power when the power is transferred to the motor, right? So that helps in driving, especially in overtaking slow vehicles easily. Next. Okay, there's one debate which is happening with regards to electric vehicles. Now the debate is basically in India, the grid is powered 60% with fossil fuels, right? The electricity which is coming today in India, the main source is still coal based, right? 60% is fossil fuel energy. Now the challenge here is you are still charging your electric vehicle using this fossil fuel based source. Does it really make sense when it comes to total emissions? So the challenge here is in India, we are yet to see like solar energy or renewable energy coming into the grid. So if more and more solar energy comes into the grid and solar energy is used to charge the electric vehicle, that is when we see the total emissions reducing significantly. So if you talk about life cycle emissions, that is the difference. Next. Okay, I'll try to summarize what we just spoke, and then we can take Q&A, question and answers from you all if you have any questions about the journey, and then we can go and see the vehicle also. So just to summarize what we just said as takeaways, one is the running cost. So think about electric vehicles, in the sense of where the running cost is low, right? So both if you charge with slow charging or fast charging, the running cost is almost 60 to 70% less today when you compare it with any equivalent petrol or diesel vehicle. So that is one big takeaway for all of you with electric vehicles. Second takeaway, I would say, we discussed the charging aspect, right? The slow charging and fast charging, both have pros and cons. Slow charging, it takes almost 12 hours, fast charging takes 2 hours, but the fast charging is not good for the battery, slow charging is good for the battery. So try to charge with the slow charging as much as possible. Do not go to a fast charger, unless you really need it, because it will damage your battery in the long run. And we also talked about regenerative braking. Right? Regenerative braking, you get energy back into the battery when you brake. So that is one interesting aspect of electric vehicles, and that you get a larger range in city driving environment. And then also, generally, if you drive at higher speeds, if you drive at 100 kilometers per hour versus 70 kilometers per hour, at 100 kilometers per hour, you get a lesser range compared to 70 kilometers per hour, right? So that difference is there in any vehicle, right? You get higher wind resistance, higher rolling resistance at higher speeds. So due to that, you get a lesser range, right? Because the battery consumption is higher in higher speeds. Next. Okay, coming to the last segment of my talk. So I want to highlight the fact that the electric mobility sector is growing a lot. It's just starting, and we see a lot of growth opportunities for students in different sectors, right from vehicle manufacturing companies to charging station companies to energy companies. All these companies are hiring people or hiring students. So if any of you are interested in mobility as a sector, electric mobility is something that you should consider, because we are very new to the whole electric mobility sector in India, and the growth is huge. In the next 5-10 years, you'll see more electric vehicles, a lot of work going on in the electric mobility sector in general. So I just want to highlight this, that e-mobility sector can be interesting for you all if you want to learn more about it and explore this career opportunity as students. Next. Yeah, so there's even in EV sector, right? So there are different topics that we can work on. These are just a few, like manufacturing side, even software side. So in fact, electric cars are nothing but it's a gadget, right? Today, electric vehicle is a gadget. So it's a software on wheels, right? It's more like a software on wheels. It's no longer a mechanical based vehicle. It's completely changing. So you have to think of a vehicle as a software on wheels kind of a base. So a lot of opportunities open up if you think about energy and mobility in a combined manner. Next. Yeah, I think we are done with the presentation in a way, but if you have any questions, specific questions that you want to ask, please feel free to do so right now, and later we can go down, see the car, you can see the charging port, the components. I think that will be interesting for you all to see. But do you have any specific questions that you want to ask about the journey, about the vehicle, about e-mobility in general? Anything that you want to know specifically? Anything, feel free to ask.
Mentioned here that throughout your journey from Kanyakumari till here, what are the problems that you majorly faced in this journey?
Okay, good question. So the major problem was the charging of the electric car. So I'll tell you one case, what happened between Bangalore to Hyderabad. So Bangalore to Hyderabad is 600 kilometers. Bangalore to Hyderabad is 600 kilometers. In any petrol or diesel vehicle, it takes 9 hours. at max, even if you consider stopping in different places for a break. But we decided to do the journey on an electric car in one single day, right? So what we did, we looked at plug share, we looked at where are the charging stations located on that route, because what was the range of the car? Just 300 kilometers, right? The car could only go 300 kilometers in one charge, but the distance was 600 kilometers. So we had to stop somewhere on the road. So we mapped out 5 charging stations, and as per the online status, they were working, and they were Tata Power charging stations. So Tata Power has the biggest network of fast charging stations in India today. So out of those 5 stations which seemed to be working online, only 2 of them were actually working on the ground. So 3 of them had hardware issues, software issues, connectivity issues. So that is where we also faced a traffic problem. So the 3 chargers were not working. So the 4th charger, there was a line of 5 vehicles just waiting before us to charge. And each vehicle wanted like a top-up charge of 20 minutes. So we had to wait like almost 1.5 hours for our turn, and then plug in the vehicle for another 1.5 hours. It was an extra waiting time of 3 hours, right? So the whole journey, instead of 9 hours on any petrol or diesel vehicle, it took us 13 hours on the electric car. So those challenges are there when it comes to charging on the ground today. So especially if you're traveling intercity, that is one big challenge. Within cities, the network of charging is still fine. If you're using the electric car for within city limits, that is good. You can at least charge in any 16 ampere 3-pin socket. But if you're continuously traveling, especially intercity journeys, that is where the problem is today. That is where the challenge is. So that is the one challenge that we face when it comes to charging. Apart from that, there was no issue with the car. We had a couple of punctures near Coorg in the hill station. But apart from that, no electronic issues. Yeah.
So, do we have any other questions for sir? Okay, I think this is it. So, sir, I would like to thank you for sharing the benefits and all the insights of electric vehicle. And as students and as the future of this nation, we're proud that we have such people who are influencing us. And sir, now I would request each and every one of you, please follow us with sir.
Main motor है इसके नीचे है, and it's a front wheel drive. तो the main motor is powering the front 2 wheels. ठीक है, पीछे के पहियों में कोई पावर नहीं जा रहा, सब यही हो रहा है जो भी हो रहा है. There's a coolant and coolant. नहीं, बाकी वाइपर के लिए पानी वगैरह रहता है, सोप पानी. But the coolant is for the main battery pack and also for the electronic components and for the motor. So coolant घूमते रहता है depending on the weather conditions. Then there is also a radiator here. Radiator fan है, यहाँ पे कुछ गर्म हो रहा है, then the fan helps to evacuate some air. This is the VCU, Vehicle Control Unit. It's like the brain of the system. जैसे आप जितना प्रेशर डालते हो ना एक्सीलेटर पे, उसके हिसाब से वो करंट खींचता है बैटरी में, बैटरी से मोटर को देता है. दिस इज़ दी ऑन बोर्ड चार्जर. एंड ये तो देखा ही होगा कहीं, बाकी गाड़ियों में भी रहता है. ऑक्सिलरी बैटरी है, छोटा सा 12 वोल्ट बैटरी दैट पावर्स लाइट्स, वाइपर्स, एनी इमरजेंसी एप्लीकेशन.
और जो ब्रेकिंग सिस्टम का कह रहे थे वो इसी से होता है, ब्रेन से?
नहीं, ब्रेकिंग नॉर्मल अपना जो रहता है गाड़ी.
आप कह रहे थे ब्रेकिंग.
हाँ, रीजनरेटिंग ब्रेकिंग. हाँ, तो वो जो मेन मोटर है ना, वो जनरेटर बन जाता है व्हेन यू ब्रेक द सेम मोटर. तो उसका ड्यूअल पर्पस है. तो रीजनरेटिव ब्रेकिंग हैपेंस बिकॉज ऑफ दैट मोटर ओनली. ऐसा है. बाकी वो फ्यूज बॉक्स है, और यहाँ पे क्लियरली लिखा है एज अ वार्निंग कि गलती से भी इसको प्रेशर वॉश मत करना पानी से. डोंट पुट वाटर. बारिश इज़ नॉट अ प्रॉब्लम, बट वॉशिंग सर्विस स्टेशन में अगर जाते हैं आप, तो नॉर्मल गाड़ियों में क्या होता है, पानी डालते हैं ना ऐसे, तो वो अलाउड नहीं है यहाँ पे, क्योंकि सारा इलेक्ट्रॉनिक कंपोनेंट्स हैं. तो शॉर्ट सर्किट, फायर, पता नहीं क्या हो सकता है, राइट. सो यू हैव टू बी केयरफुल. एंड दिस इज़ अ 400 वोल्ट आर्किटेक्चर. तो जो मेन आर्किटेक्चर है गाड़ी का हार्डवेयर का, दैट इज़ 400 वोल्ट्स. तो हाई वोल्टेज है, सो यू हैव टू बी वेरी केयरफुल. बाकी जो मेन बैटरी पैक है वो नीचे है बिटवीन द व्हील्स. एज अ बेस. तो यहाँ पे दिखेगा नहीं वो लिथियम आयन बैटरी. इट इज स्प्रेड आउट अंडरनीथ द पैसेंजर. मतलब अगर आपको झुक के देखना है नीचे गाड़ी के तो आपको दिखेगा ऊपर बैटरी, बट इट्स ऑन द बेस. And the main reason of the battery on the base is the fact that the most mass component of the electric car is of the battery, right? Battery is the heaviest component. तो क्योंकि वो नीचे है, the center of gravity is low and center, तो stability बहुत अच्छी रहती है गाड़ी की. You can take faster turns and वो roll over chances कम रहते हैं in any electric vehicle because the mass is low and center. Compared to any engine जो सामने मास रहता है, right, which is bit unstable compared to EV.
कितना कॉस्ट करती है?
यार commercially I think around Mahindra is selling it for 18 lakhs, 19 lakhs. हाँ, 18-19 lakhs. या ये इसका competition है टाटा नेक्सॉन. हाँ, टाटा नेक्सॉन EV, सेम रेंज, सेम परफॉर्मेंस, सब सेम. नहीं यार, टेस्ट ड्राइव नहीं दे रहे हैं.
सर अब कौन सा स्टेट है सर?
कुछ सवाल वगैरह हैं, पूछना है कुछ? अच्छा, एक बार वो चार्जिंग पोर्ट देख लेते हैं. उस तरफ आना, उस तरफ आना.
सर इट्स योर 44th और
43rd डे.
43rd.
हाँ, 42 डेज हो गए हैं. उस तरफ वो है चार्जिंग पोर्ट है, वो देख लेते हैं एक बार, है ना. Port like your laptops have adapters. Similarly, electric cars come with this adapter. So the biggest advantage is this 16 ampere 3-pin socket. तो आपको कहीं भी usually मिल जाएगा, right? It's a heavy load equipment socket. In fact कल रात को भी मैंने इसी से चार्ज किया यहाँ कैंपस में. तो that is the best advantage, the access to any 16 ampere 3-pin socket. But there is a challenge with the length. 4 मीटर का ही लेंथ है, राइट. तो इट्स ऑलवेज डिफिकल्ट टू फाइंड एक्सेस पॉइंट एट अ लेंथ ऑफ 4 मीटर्स. तो हम लोग एक एक्सटेंशन कॉर्ड कैरी कर रहे हैं 10 मीटर लॉन्ग. तो इवन इफ इट इज़ 15 मीटर लॉन्ग द एक्सेस पॉइंट, एटलीस्ट वी हैव एक्सेस टू दैट विद द एक्सटेंशन कॉर्ड. बाकी सो दिस इज़ कॉल्ड द CCS, चार्जिंग कंबाइंड चार्जिंग सिस्टम. दैट इज़ द चार्जिंग पोर्ट स्टैंडर्ड ऑफ एनी इलेक्ट्रिक कार. अगर किसी को प्लग इन करके देखना है, एनी वॉलंटियर जस्ट वांट्स टू एक्सपीरियंस द प्लग इन एक्सपीरियंस, आ जाओ. किसी को प्लग इन करना हो तो देखना, वो पिन विन मैच करके प्लग इन करना. ठीक है, हो गया बस. सिंपल है. द गुड थिंग इज वंस यू स्टार्ट चार्जिंग दिस गेट्स लॉक्ड इन. सो कोई इसको खींच नहीं सकता चार्जिंग के टाइम पे, है ना. सो दैट इज़ द सेफ्टी स्टैंडर्ड, सेफ्टी फीचर. Sorry?
What's this machine for?
This is for charging the electric car.
Oh.
Yeah. This is a portable
Also it's
charger.
an electric car.
Electric car, yeah.
Oh, both electric and
No, only electric.
no fuel.
No fuel.
How many hours does it have?
300 kilometers in one charge. It takes 12 hours to charge. 12 hours.
12 hours.
Yeah. It's a slow charger. For fast charging. तो आप फास्ट चार्जिंग स्टेशन पे इसको लेके जा रहे हैं, तो यू हैव अ बिगर कनेक्टर, क्योंकि उसमें पावर ज़्यादा रहता है. प्लस यू नीड मोर सेफ्टी इक्विपमेंट इन अ फास्ट चार्जर, एंड यू कांट कैरी अ फास्ट चार्जर. स्लो चार्जर है, यू कैन कैरी अलॉन्ग, क्योंकि उसमें सेफ्टी फीचर्स कम रहते हैं. चार्जिंग करंट इज़ वेरी लेस. बट फास्ट चार्जर में हाई पावर, हाई करंट, you need a high safety equipment, and you can't carry along with that. So and also you need special protocol safety features for fast chargers, but otherwise this is a standard. What else? कुछ और जानना है तुम लोग को?